Hey there. So I figured now is a pretty good time to kind of document where I'm at on this project I've been working on for the last couple months. I haven't really worked on it in probably 2 or 3 months. It took me a couple weeks to put together. But now's a really good time, I think, to just go ahead and document it and show people what's up. So basically, what I have here, what I'm working on, is a vending machine brain. Right? It's called the Ultra-Dozo robot brain, just a name. Um, but one of the things there's two things that I'm trying to accomplish with this right now. One is inventory management for vending machines. Right now, the only way to really do inventory management, or the way it's done most commonly, is either there's no inventory management at all, and you have to do it on site, or um, you can go through the card reader. So if a user or a customer uses a debit card, you can get an idea of some of the stuff they got, and you can basically deep dive into that transaction and try to make it make sense as far as inventory goes. But a lot of times you don't know exactly what they bought, or how much you have left or anything like that. You just have to do the math yourself. Anyway, the way I'm accomplishing that is with an actual database. Right now it's a MongoDB, but we'll move that into SQL, SQLite type deal later for embedded. The components are, this is just a relay board that's connected to the GPIO of our compute board, and our compute board is a Xavier NX. I really like to prototype with these because I can prototype with some pretty heavy non-compiled stuff, so I can use like Python and Mongo to get my ideas out. But I don't have to, and then I can, start to make the footprint a lot smaller. I can optimize later, right? And then what we have here is the little echolocation ultrasonic sensor, the SR04 or whatever. And the way this basically works, there's two things. There's the inventory side, right? And there's a Mongo database that actually keeps track of the inventory, and we'll go into that in a second. And then the ultrasonic sensor actually detects if something has been dispensed. So how many times have you actually, you went to a vending machine and it's gotten stuck? Like especially the snack machine. You can see, what you basically took your money, you put the money in, it rotates the spirals, and your thing hangs on for dear life and doesn't come out, right? Well, what this is designed is if anything comes within a set range, so right now it's set at 150 centimeters. If anything passes it, it detects it and will flag it as detected. If not, it says, hey, this wasn't detected, and we can add logic to that to redispense things. So I did a lot of research on vending machines. I've always thought they were really cool, and kind of like what the business practices behind those, and like ownership and management, and inventory was the biggest problem, and then going out to fix their crap was a really big problem. So it's the theory behind this is it's a lot cheaper to redispense something automatically, especially if it's like $1, than it is to go all the way back on site and actually have to fix the machine or reimburse people or lose your customers because they don't have faith in your machine. Anyway, so let's get into how this thing actually works. So again, there's a database on it. I'll show you a little bit of it here. It's not a really good screenshot, but basically we have a record of a vending machine. And the vending machine is made up of a couple parts. And it's mostly so there are the actual slots in the vending machine, right? And then each slot has inventory, and it also has DC motors. So we can do a technical deep dive later, but really the way the inventory system works is you have serialized inventory. So like, for example, I think a Coke that's the serial number for it. And those items are assigned to slots, and those slots have DC motors. And so on the back of a regular snack vending machine, there's just DC motors. I think there's actually even just a relay board that's attached to DC motors. So what we do is if you notice the spiral, right? The spiral is attached to a DC motor, and a revolution can be determined based on time. So what we do is we pull pins up on GPIO for a set amount of time. So if a DC motor takes 5 seconds to do a 360-degree rotation, we pull the pin up for 5 seconds. Whatever the DC motor connected to whatever relay then turns on for 5 seconds, and concurrently we turn on the ultrasonic sensor and start checking for readings. So the idea is whenever user selects item, whatever item they select is associated with a GPIO pin, basically, that's associated with a DC motor that's associated with a relay. Anyway, hit select what you want. GPIO pulls up, turns on relay, spins motor, and concurrently turns on the ultrasonic sensor. So while it's dispensing, anytime between whenever the request has started to the end of the rotation, that's whenever we start to actually try to capture data. So I'll do a demo right now. Oh, and then we also update the database, right? So select what we want, turn the stuff, check if it was dispensed, update database with the correct inventory so you can know what people bought. Anyway, but we'll do a test run and you'll just kind of see how it goes. So flip that relay on, so whatever motor's connected to that would start spinning, and it did all that. So I have it running, and here's the updated record, and you can see right here, item was not dispensed. So check this out. We're gonna make a dispensed item. So here it goes. I'm just gonna flick my hand over it. You can see that was detected, and it gave me clean records with timestamps and the actual distance in centimeters. So item was successfully dispensed. So we don't have to have any logic, and you can look that. Just take my word for it. In inventory slot in this inventory, there were, I think, 10. I think I started out with 10. Oh, okay. So I rebuilt some of this earlier, and it doesn't actually update the database entirely. But take my word for it, it can. Oh, no, there it goes. Yeah, stock remaining. There we go. So it was at 10. It's at 9 now. And if we run it again in that same slot, it's all pre-programmed to run in that same slot. Oh, and there we go. I had to do some motion. And let's see if it goes down to 8. Oh, it probably doesn't go down to 8 because I reset the database every single time. Okay. But anyway, so those are the basics of what I have. This is all running through right now a Flask API and a Kubernetes cluster. The idea was originally the service that ran the ultrasonic sensor was its own service, and the service that ran the database was its own container. So I was going to split them up into containers that were microservices, but it seems pretty dumb. And also, I built this in Python and with Mongo. I am going to actually refactor this in Go, so I can use Go routines to knock all this stuff out, and it will be compiled, so it'll be a lot lighter, because I really eventually want this to run. This is kind of an expensive compute board, and it's getting a little bit overkill. I want this to eventually run on something like Jetson Nano. Like this is a Jetson Nano SOM, so it's $99 instead of $300 or whatever this is. But these are getting cheaper, and NVIDIA is going to drop some stuff later at some point. So, and the idea is that this can be a very general purpose compute unit. So we can add more functionality, like all types of really cool. We can do facial recognition. We can do we can have it keep a memory without connecting to the cloud of the user, right? Or it can also connect to the cloud, right? So I can add like any type of like a cellular chip to it or something like that, a cell hat or something like that, and get it to work and connect to the cloud and keep all your metrics and stuff there. But it's able to do a lot of these AI tasks. So these things that I showed you are not AI tasks, but I can couple these with whatever types of AI tasks that I want, like facial recognition, natural language processing, speech to text, all that type of stuff, and make a pretty good vending experience and make it very reliable. That was the point of this. Is vending machines are very, very unreliable, notoriously unreliable. And they're very simple, and they just need a little bit of extra help. So anyway, this is the start of my vending machine projects, I guess. Again, I built this several months ago and haven't really messed with it. But I'm going to refactor some stuff, make it make a lot more sense, and see if I can add some features. But yeah, this was the Ultra Dozo. It's Japanese. Ultra Dozo robot brain. So the idea is that you replace the compute unit in the vending machine, particularly a snack machine at the moment. With this compute unit, this board, you wire the DC motors to these relays, and it's plug and play. So anyway, appreciate you watching.